This is Rania, your math teacher. Today we will study a new lesson which is repeated multiplication. Before starting our new lesson, I want you to remember something. What is the meaning of repeated addition? What is the meaning of repeated addition? For example, if I'm adding 2 plus 2 plus 2 plus 2. So I repeat 2 4 times and I'll add each of them. So it will be what? 2 plus 2 plus 2 plus 2. Yes, it will be 8. What did I do? I'll multiply 2 by 4. I multiplied 2 by 4. So multiplying is a repeated addition. Okay, I know now that multiplying is a repeated addition. But if I want to repeat the multiplication, what should I get? If I want to repeat the multiplication, for example, if I repeat 6 by 6 by 6, so I'll repeat the 6 3 times by multiplying them. I'll get a new concept which is power or exponent. So it means 6 up to the power 3. So if I'm using the repeated multiplication, so here we have a new concept which is powers. We are using the powers. Here the 6 is our base and 3 it's our power or exponent, which means I'll repeat this 6 3 times. So I'll repeat the 6 according to the number of the powers by multiplying it by itself. So 6 to the power 3, it means 6 by 6 by 6. And I could read it as 6 up to the power 3, which means 6 by 6 by 6. Okay. 6 is called the base and 3 is called the power of or exponent or indices, whatever. Here I have our usual number or our usual integer, which is like 4, for example. When I said 4 and that's all, I will not say 4 up to the power what? What does it mean? It means 4 up to the power 1 because it repeated just 1 times. So if I put any integer without putting any power up to it, it means this integer have the power of 1, but I don't write this 1. Okay? So 4 equals 4 up to the power 1, but we will not put the power or say it. Okay? Power 1, we will not read it. Let's see. Here we will say any number except the 0, any number except the 0 to the power 0 equals 1, which means 8 to the power 0 equal 1. So 8 to the power 0 equal 1. 6 to the power 0 equal 1. Negative 4 to the power 0 equal 1. Any integer up to the power 0 equals 1 except the 0. Here when we will multiply two numbers with the same base, we will add the powers. If I'm having same base, I'll add the power of them. For example, a up to the power m multiplied by a up to the power n. Here, where is my base? It's a. And the power are m and n. So I'll take the same base, it will be a up to the power m plus n. Let's see an example. 5 up to the power 2 times 5 up to the power 3 equals 5 up to the power 2 plus 3, which is equal 5 up to the power 5. Again, if I divide two numbers having same base, always we have same base, I'll subtract the power of them. A up to the power m divide 8 up to the power n equals a up to the power m minus n. For example, 7 up to the power 9 divide by 7 up to the power 6 equals 7 up to the power 9 minus 6, which means 7 up to the power 3. Okay? Another property. Here, if I have a negative integer up to the even power, negative integer up to even power, so the answer will be positive. Why? For example, negative 2 up to power 2 equals 4. How? Because negative 2, I'll multiply it by negative 2. We said before, 2 same sign will give me positive. So negative multiplied by negative, it will be positive 4. And of course, you remember, even numbers are 0, 2, 4, 6, 8, all the multiple of timetable 2. Another property, negative numbers up to odd power. Negative numbers up to odd power. The answer must be negative. Okay? For example, negative 2 up to power 3 equal negative 8. Why? It's negative 2 multiplied by negative 2 multiplied by negative 2. Negative by negative equal positive. And after that, positive by negative equal negative. So the answer must be negative 8. Okay? And you remember, of course, the odd numbers are 1, 3, 7, 9, and so on, which are not multiple of 2. Here, we could read these powers in another way. For example, I could say 2 up to power 2, or I could say 2 squared. I could say 2 up to power 3, or I could say 2 cubic. So, if I have power 2 up to any integer, it could be said as a squared of. Or if I have power 3 up to any integer, I could say a cubed of. Let's see an example from your school book. Find the value of each of the following. Negative 7 up to power 2. Here I have even power for odd integers. We said if I have negative integers, we said if I have negative integers and even power, so the answer must be positive, so the answer will be 49. Letter B, negative 5 up to power 2 multiplied by 2 up to power 2. Okay, take care. Here I have different base. Okay, they are not same base. So I can't add or subtract the power of them. I must solve each one individual, and after that I'll take the product of them. So negative 5 up to power 2, it will be 25. 2 up to power 2, it will be 4. I'll multiply 25 by 4, it will be 100. Letter C, negative 2 up to power 4 plus negative 3 up to power 3. Here I have different base and it's addition, not multiplication. I'll solve each integer individual. After that, I'll add them. Negative 2 up to power 4, it's 16. Negative 3 up to power 3, it's 27. So add them, it will be negative 11. Letter D, negative 1 up to power 100 plus negative 1 up to power 101. Okay. Let's see the first power, which is 100. 100 is an even power. So the answer here will be 1, positive 1. While 101 is an odd power. So I will not cancel the negative. So the answer will be negative 1. 1 plus negative 1, the answer will be 0. Letter E, negative 4 up to power 3 multiplied by negative 1 up to power 5. The first integer will be negative 64 multiplied by negative 1. Two negative numbers multiplied by each other will give me a positive integer, which is 64. 2 up to power 3 plus 2 up to power 2. Okay, take care here. Here we are adding the numbers. Don't mix adding and multiplication. I can't add the power in addition, okay? I'm adding the power only in multiplication. Here, I'll solve each one individual. 2 up to power 3, it will be 8. Plus 2 up to power 4, up to power 2, it will be 4. So the answer will be 12. Our last example. Find the result of each case of the following. Okay, concentrate here with me, please, all of you. I have 2 up to power 6 multiplied by 2 up to power 5. All of them are divided by 2 power 3 times 2 power 5. Okay, all of them are, the base here is 2. I'll start by answering the numerator. After that, I'll go to the denominator. Here the base is 2, so I'll add the power. It will be 2 up to power 6 plus 5 over 2 up to the power 3 plus 5. The numerator will be 2 up to the power 11 divided by 2 up to the power 8. Now I have division, so I'll subtract the power. It will be 2 up to power 11 minus 8. The final answer will be 2 up to power 3 equals 8. Okay? Letter B, negative 3 up to power 3 multiplied by negative 3 up to power 4 divided by negative 3 up to power 5 equal, I solve the numerator first, after that the denominator. So the numerator has power 3 and power 4, I'll add them. So it will be negative 3 up to power 7 divided by negative 3 up to power 5. I said divided by, which means I'll subtract the powers because I have same base. It will be negative 3 up to power 7 minus 5 equals negative 3 up to the power 2. Of course, 2 is an even power. The answer will be 9. Letter C, negative 8 up to the power 3 multiplied by 8 up to the power 4 divided by negative 8 up to the power 7. Here I have what? I have different bases. I have negative 8 and 8. So I'll start by taking the negative sign and I'll put it outside the bracket. Negative sign of the numerator. It will be negative, and after that it will be 8 up to the power 3 multiplied by 8 up to the power 4. Now I have same base, which is 8, because the negative is outside the bracket. So I could add the powers now. So the numerator will be negative, open bracket, 8 up to the power 3 plus 4 over negative, outside the bracket, over 8 up to the power 7. Here, the numerator, the adding of the powers will be 7. It will be negative 8 up to power 7 divided by negative 8 up to power 7. Same numbers are divided by each other. The answer will be 1. The last example, 9 up to power 6 multiplied by negative 9 up to power 6 over negative 9 up to power 5 multiplied by 9 up to power 2. Here, look to the numerator. Negative 9 up to power 6, I have an even power, which means I'll cancel the negative sign. So the numerator here will be 9 up to power 6 plus 6. Okay? And the denominator, I'll take the sign out. It will be negative 9 up to power 5 plus 2. Now, I'll make the division, which means I'll subtract the power. Negative, open bracket, 9 up to power 12 minus 5, minus 7, sorry. The answer will be negative, open bracket, 9 up to power 5. So the final answer here will be negative 59,049. Okay? I hope you enjoy your new lesson and your new concept. Please practice on it and see you soon. Thank you.